What on earth?
Hey, Shihil.
Hey, Josh. So?
Holding up cracker again?
Hey, you know something? I have no idea what this is, and I think John is supposed to be here, but he's not here right now.
Well, we kinda need him to do this.
Hey guys, I'm here with my TI Inspire CX Cast, brought to you by Texas Instruments.
Okay, so now we need to grab the materials. So we are going to need
The
our...
first thing we need are optical lens protectors.
and also our fabric body protection shields.
Optical lens for protection. Oh, goggles.
I think this is just that one.
And then fabric body protection shields are aprons.
Now we have our goggles and our lab equipment. But where's Greg?
Guys, sorry I'm late, but I found a computer.
That's not just any computer. This is a Spark Science Learning System, brought to you by Pascal.
And this is the colorimeter we needed, also brought to you by Pascal. And it came with 5 of the keypads just like these.
Alright, we will also need 2 100 milliliter beakers, a 50 milliliter volumetric flask, a 0.2 molar iron 3 nitrate solution, and a 1.0 molar nitric acid. And then we will also need a 0.002 molar iron 3 nitrate solution in a 1 molar nitric acid and a 0.002 molar thiocyanate solution.
And we will also need a potassium thiocyanate solution of unknown concentration, a stirring rod, and tissues. And remember, for the nitric acid, you want to have Mr. Ozuna prepare it for you. You don't want to prepare it yourself, because that could be very dangerous. Take it from us.
Young scholars, here's what we're doing. This lab is titled Colorimetric Analysis, and we'll be finding 3 things. The absorbance of 5 standard ferrothiocyanate solutions, calculating a standard curve or calibration curve from the test results of the standard solutions. And finally, the absorbance of a thiocyanate solution of unknown molar concentration and determining its concentration using our calibration plot.
To test the absorbance, we'll be using this colorimeter, which will analyze the solutions at blue light, or about 470 nanometers. That's the wavelength. Remember that the absorbance is the optical density, or the amount of light taken into the solution.
Basically, a higher concentration of solution will absorb more light than a solution of lower concentration, and will also transmit less. Absorbance versus concentration should yield a direct relationship, and this direct relationship is known as Beer's law.
Did somebody say beer?
John, none of us are 21.
Yeah, come on, man.
I know people.
Anyway,
He knows people.
so now that we know all the info, we can start the lab now. With the colorimeter, you first connect it to the spark, press build, and then we want blue.
Absorbance. But we want absorbance, not transmittance, Josh. You gotta get it
Yes,
right.
that is true.
No.
Master So! Fail.
Alright, now you press numbers. And
Okay.
we are ready.
Now, in order to do this, you're going to want to calibrate your sensor by putting a cuvette with distilled water in there. So, take
The
cuvette.
distilled water is over here. Ooh.
So you will use that to calibrate before each time you put a different cuvette in.
We need to create a calibration plot, which is a graph of absorbance versus concentration. To do that, we can just use our TI Inspire CX Cast. We just open up lists and spreadsheets, enter the values for concentration over here, and we can enter the values for absorbance over here. So let's just call this X and Y. Next, we open up another page and call it Data and Statistics. Enter concentration, which we said was X, and then Y for absorbance. And we're done.
Your value should show up there, and then you just use the data to find a regression curve.
Yes.
Okay, now we have all our materials, and we have prepared our solution for standard 1, or trial 1, whichever one you wish to call it. And so we're going to do that as an example.
So now we can record the absorbance values of this part?
Correct. As long as this cuvette right here is 3/4 full. Make sure it is full. This is very important.
Why?
Because we want to make sure the light will pass through all solution, not be able to pass around the solution.
Okay.
Oh yeah, John, crazy kid.
Now we put the cuvette in the colorimeter, close the lid, and press go.
Pressing go.
And now we just wait for 2 minutes.
Tick tock. Tick tock. Tick tock.
Okay, it's now 2 minutes later, and we can just press stop.
Thanks, Shinyu.
Nice.
Now we record the number where it says absorbance. And then we will do the exact same process for the other 4 cuvettes, as well as the unknown solution which Unseen will give us for step 6.
Hold it! Don't forget to throw away the solution.
Ah, yeah. Generally, we can just dump it down the sink unless Mr. Ozuna says otherwise.
He's dumping.
Dude, that's crazy!
Crazy.
Hey, Greg, you want to give us a recap?
Sure, Shaquille. In this video, we learned that absorbance is the amount of light that is absorbed or taken into a solution. A colorimeter is a device that can measure absorbance by passing light through a solution. Solutions with higher concentrations will absorb more light. Beer's law is a direct relationship between absorbance and concentration of a solution.
Snap, Greg, you learned a lot.
No, dude. It's crazy how much you can learn from doing a lab like this.
Yeah.
So, remember,
Everyone can learn
Chemistry.
But only cool kids can use chemistry.